got another question here on the binomial theorem, and we are asked to expand 2x squared plus 1 over x minus x cubed. Now earlier in the previous examples which we did, we only had 2 terms, but in this case we have 3 terms and we need to work with them. So how do we do this? Basically in this we need to group terms. So I can have 2x squared plus 1 over x minus x. I'm having this whole thing as one term, power 3. So this is my second term. So essentially this becomes my a, and this whole thing, the whole bracket 1 over x minus x, becomes my b. So from there on I have something similar to a plus b cubed. We can use the binomial theorem and get the answer to this. So let's start. So we have this, we have a plus b cubed. So our first term is gonna be 2x squared, the whole thing cubed, plus 3 choose 1 into 2x squared power 3 minus 1 into 1 over x minus x power 1 plus 3 choose 2 2x squared power 3 minus 2 into 1 over x minus x power 2. So we've got that ready, and then the last term will be 3 choose 3 2x squared power 3 minus 3 into 1 over x minus x cubed. Now this becomes the last term of the expansion, and I'm sure by now you must have known why it is. If you still need some revision, you could just look at our previous videos. So this is what we are working with. So let's start. Let's go ahead and expand it out. So we have 2x squared and the whole thing is cubed. That's the same as 8x power 6, because 2 times 3 is 6. So 8x power 6 and 2 power 3 is 8. So I have that. Then what's 3 choose 1? Let's solve that. I want you to actually solve this on paper and not use a calculator, or else you might lose the concept. That's why I'm insisting on solving all of these questions on paper, so that it helps you more. You could use a calculator, the calculator will give you a direct answer, but again you might be at a loss at this. So this is the same as 3 times 2 times 1. This is 2 factorial, which is 2 times 1 times 1, because 1 factorial is just 1. So this goes, and therefore I'm left with 3 as the answer. Therefore 3 choose 1 is 3. So basically the answer is going to be 8x power 6 plus 3 into, this is 2x squared power 2. So that's going to be 4x power 4 into 1 over x minus x plus 3 choose 2. What's that? That's going to be 3 factorial over 3 minus 2 factorial into 2 factorial. So that's 3 times 2 times 1. This is 1 factorial. So that's just 1. So 1 times 2 factorial, 2 times 1. I'll cancel this out and I still get my answer as 3. So 3 choose 2 is also 3. So 3 into, this is 2x squared power 1, because 3 minus 2 is 1. So it's just going to be 2x squared. This is going to be 1 minus x squared minus 2 into 1 over x into x. So these will go, so I'm left with minus 2 plus x squared. In case this is not very clear to you, let me just elaborate a bit on this, because this is something very similar to a minus b squared, where my a is 1 over x and b is x. So this is the same as a squared plus 2 into a into b, but always take into account the sign. So this is minus, so it's going to be minus b plus minus b squared, which is just a squared minus 2ab plus b squared. So I've just used that. So my a squared is 1 over x squared minus 2ab, so minus 2 times this, and 1 over x times x gives you 1, so it's just minus 2 times 1, which is minus 2, plus b squared. My b is minus x, always take into account the coefficient, so minus x times minus x gives you positive x squared. So I've got that. And then let's continue. We have this bit. So 3 choose 3, that's 3 factorial over 0 factorial into 3 factorial, which is 1. So all I have to do is just write it as, because 2x squared power 0 is also 1, this is just going to be 1 minus x, 1 over x minus x cubed. So that's how it works. Now I'll have to go ahead and expand this. So let's first expand 1 over x minus x cubed. Now again, this basically requires me to use the binomial theorem again. So in other words, this is a binomial theorem question inside a binomial theorem question, because I need to use 1 over x minus x cubed. I need to expand that, and it's gonna be some work, so I'll have to use the binomial theorem. So this is the same as 1 over x cubed plus 3 choose 1 into 1 over x into minus x. I'm just using the theorem. 3 choose 2 into 1 over x power 3 minus 2 minus x power 2. So it's just basic use of the theorem, so I hope you are able to follow, and I'll complete the last term. So that's 3 choose 3, 1 over x power 3 minus 3 minus x cubed. So that's how I'll be expanding this. So I've got 1 over x cubed, 3 choose 1 into this, 3 choose 2 into that, and 3 choose 3. So I've already got the values of these over here, so I don't really need to do the working out again. So this is 1 over x cubed minus, because of the minus sign here, so this is 1 over x squared. So this is the same as 1 over x squared in this form. So I'll be multiplying this with x because of the x on this side, so I'll just be cancelling out, so it's just going to be x that's left here. So basically, since 3 choose 1 is 3, it's going to be 3 times 1 over x squared times x. So that gives me 1 over x, because 1 over x squared times x is equal to x over x squared, which is equal to 1 over x. So that's done. 3 choose 2. 3 choose 2 is also 3. We had got that here, and this is a minus sign, but you're squaring it, so you end up with a positive sign. You have a plus sign. So the way how this will be done is the plus will still stay, so it's just going to be plus 3 choose 2, and 3 choose 2 is 3, so 3 into 1 over x, because this is 1 over x power 3 minus 2, which is 1 over x power 1, times x squared. The last bit, it's just going to be minus x cubed, because 3 choose 3 is 1, and 1 over x power 0 is also 1, and minus x cubed is just minus x cubed, so it's just the way how it's going to be here. So this is basically the expansion of how it's going to be. So let's write it. So it's 1 over x cubed minus 3 over x plus 3x because this x cancels out with that, so you're left with 3x minus x cubed. So basically what I've written down here is the expansion 1 over x cubed minus 3 over x plus 3x minus x cubed. So that's the expansion of this thing written in red, 1 over x minus x cubed. So now that we have the expansion, we can go ahead and actually get the value.